I recently obtained a copy of a paper tape that contains the very first version of BASIC released for the Altair, version 1.0. This was released in March of 1975 and was the precursor for what later became 4K BASIC and 8K BASIC that we're more familiar with. Now, in terms of a memory footprint, this version would be considered about a 6K BASIC, although feature-wise it was pretty much the same as what later became 4K BASIC. Now, if you think about it, in creating 4K BASIC from this original 6K version, Bill and Company reduced its size by a third and kept all the original capabilities of it. If you think about it, that's a pretty good accomplishment in creation of 4K BASIC. Alright, now at the time this tape was released, the standard paper tape and cassette format that you've seen me demonstrate and describe how it works in other videos, that format hadn't been developed yet. So the layout of this tape is going to be a bit different. This tape is basically just a binary image of BASIC ready to load directly into memory, just starting at address 0 and going on up. And as you might expect then, the program we enter on the front panel to load that tape, the Bootstrap Loader, is different than the Bootstrap Loaders we've seen in other videos. Now, I don't have an exact copy of the original Bootstrap Loader. That would have been provided in hard copy format with the manual that came with BASIC, so I had to write my own, but I think I've gotten something that's very close to how the original would have been. It's just 20 bytes long, and in order to save you the pain and agony of watching me enter it, I've already got it entered here on the front panel. We'll go ahead and put the address of that in. It actually resides at address 011000. I'll examine that address. That's the first byte of the loader, and it's also set the PC to that address, so when I hit run, we'll be running the Bootstrap Loader. This has to reside at the top of BASIC, just beyond where BASIC will load, so that as BASIC is loaded, we don't clobber ourselves. Alright, so that's ready to go. I'm going to go ahead and hit run. This is the Bootstrap Loader that will read the tape from our teletype. Alright, and then we'll come over here to the teletype, and I will just hit run on the tape reader to get this process going. Now, unfortunately, this is a long process. It takes about 10 minutes, so we'll do a video cut and come back and catch up on this when it's just about done. Alright, this is almost done. While we wait for the last little bit, let me show you my de-spooler and spooler. The de-spooler is a paper towel holder found in the trash my wife has thrown out. The spooler is a mechanical wound winder made by Benell from the 1940s. You can see the tensioning arm controls how fast that the spool will take up. This makes it keep pace with whatever device is feeding it. It can go a lot quicker than that, actually. Now this tape is about to finish. When it finishes, it's not going to automatically start BASIC like we've seen with the other ones in the past. The reason is because this does not have the checksum loader. Therefore, there is no concept of the go record to automatically start the loaded program. Instead, we're going to have to manually stop the machine and start it running. Alright, almost done here. Get the video here. Alright. That's the end of that. I'm going to stop the machine, hit reset, and hopefully when I hit run, we'll see BASIC come up. Okay, let's see if we can read that. Right, it's asking for memory size. Now in other BASICs that you've seen before, we could hit return here and it would size BASIC for us. However, in this version, that feature hadn't been implemented yet. So what happens here, if you hit return, it just uses the amount of memory that happened to be saved when this tape was written. I'm going to go ahead and type in 8K BASIC. I've got to make room for me to type here. Right, so I'll type in 8192. That's 8K of RAM I'm saying we have, which is typical of the system sold at this point. If you look at the literature, it's typically sold with about 8K of memory. Okay, want sine, cosine again. This is like you've seen in the 4K and 8K BASIC in order to save memory. We'll just go ahead and do that. Alright, you see the sign-on is a little different. It doesn't say anything about Altair BASIC or copyright MIPS or anything Microsoft yet. At this point, I think all that was still up in the air, and they just wanted to get this version out a little bit sooner, so some of that wasn't decided. First off, you'll notice that the prompt is ready instead of the more common OK you're used to seeing. Ready, of course, was the standard of Dartmouth Basic. They eventually changed that to OK when they developed 4K Basic to save 3 bytes. Also, the command that erases program memory new, you'll see that's not accepted by this version of Basic. Instead, it's the original Dartmouth command scratch is used to erase the program memory. Now, that again saves 3 more bytes. So there are 6 bytes on the way to 2K, but you can see the kind of things they did. So the new that we're accustomed to, the OK that we're accustomed to, was all originally just ideas to save a little bit of memory. All right, I'm going to go ahead and type in a quick little program. We'll do a for loop. Let's do 1, 5. And we'll just have it print the line number and the loop counter. And run it. Okay, I have to hit delete here. Now, delete in this version of Basic is underscore, like you're used to in 4K and 8K Basic. If you ever wonder why they chose underscore as the delete character, it's because the ASCII character underscore is sent on a teletype by Shift-O. And you see that Shift-O is a back arrow. So by typing Shift-O, you send an underscore, and that's a back arrow on a teletype. Which, of course, that kind of feels like you've sent a delete, you want it to go backwards. So that's, by the way, where that came from. Try that again. Program running. Again, you can see the scratch. This is what actually deleted our program. Alright, so there you have it, the very first version of Basic for the Altair. Alright, now the computer used in the video today is actually an Altair 8800 clone computer. This computer accurately duplicates the look, the feel, features, and performance of the original Altair, but it does it with modern hardware on the inside so that you don't have to worry about damaging a vintage computer or getting it up and keeping it running. So for a great way to run through all these exciting exercises from this great period in computing history, take a look at the Altair clone and learn a little bit more about it.